A Formula One car requires an entire team of experts to function. There are thousands of individual components involved, and with so much precision needed, the tiniest mistake can ruin it all. Here's everything you need to know about the making of a Formula One car. Now, as it turns out, making a Formula One car is a lot more complex than it looks. It's 100 times harder than anything you can imagine. That's because a single car is made up of almost 14,500 individual components. And guess what? Teams churn out a brand new one every single year. But here's the thing, while each car is unique in its design, it still has to play by the rules. Yep, there are strict regulations dictating everything from dimensions to weight limits and materials. To keep things budget-friendly, some parts have to be standard across all cars, while others, like gearboxes and clutches, can be swapped between teams. But here's where it really gets interesting. The journey starts long before you see that sleek machine zooming around the track. Top racing teams start planning their cars more than a year ahead. They pay close attention to details, first by asking drivers for their opinions on the current car. Next, the engine and the chassis experts work with the design team to create a basic plan, which then gets developed into a complete design. As the design becomes clearer, the focus shifts from improving this year's car to making next year's car. During the winter, they make all the necessary parts, and then the new car is finally put together. That's when it's ready to zoom to a podium victory. But remember, doing all this is much harder than it sounds. So let's dive deeper into the actual process, shall we? These intricate cars are made so amazingly with thousands of little details involved, mainly because of the effective design team. These people are like a well-oiled machine, divided into different groups like transmission electronics, mechanical aerodynamics, and composite design. Together, they pump out hundreds of 3D CAD models every single day. And when it comes to F1, aerodynamics is the key. It's where the big performance gains are made. That's why there's a massive team solely dedicated to aerodynamics. In fact, it's so massive that it's often split into many subgroups, each with its own focus area. These aerodynamic experts put their designs to the test using computational fluid dynamics, each with its own focus area. These aerodynamic experts put their designs to the test using computational fluid dynamic simulations, or CFDs. They virtually test different aero parts to see which ones perform the best. Once they've got a winner, it's off to the wind tunnel for real-world testing. Here, a 60% scale model of the car faces a powerful fan that blows air over it at high speed, simulating track conditions. Sensors record everything from speed and pressure to downforce, while the car is tweaked to mimic on-track maneuvers. But designing is just one part of the whole process, because after that comes manufacturing. About 80% of the car is made from composites, mainly pre-preg carbon fiber. With giant rolls of this carbon fiber stored in freezers to keep them fresh, any impurities could spell disaster. So the composite areas of an F1 factory are like sterile labs, with strict controls on air pressure, humidity, and temperature. Workers wear their overalls and get to work making carbon fiber parts from epoxy resin patterns, precision cut to accuracy levels of just 0.05 of a millimeter. It's precision engineering at its finest. After that comes turning those epoxy resin patterns into actual parts. First up, the patterns are used to create a female mold using carbon fiber. This mold serves as the blueprint for the final parts. The carbon fiber matting is precisely cut into shape and laid up by hand, guided by a computer system that ensures laser-sharp precision. Keep in mind that the number of layers and the direction of the carbon fiber strands play a crucial role in determining the part's stiffness and strength. More layers mean more stiffness, while the orientation of the strands determines their strength properties. So the parts are laid up with different orientations for each layer to achieve the desired properties. Some clever engineering even involves bending the rules a bit, creating wings that are intentionally weaker in certain areas to flex under load, giving them an edge on the track. Once the layup is complete, it's time for the magic to happen. The mold is placed in a vacuum bag and baked in an autoclave, essentially a giant oven. The high temperatures melt the resin, and when it cools, it sets to create a solid, lightweight part. For larger or more complex parts like the chassis or wing, they're often made in 2 or more sections and then carefully glued together. But wait, there's more. A big chunk of manufacturing involves metal parts, with aluminum alloys and exotic metals taking center stage. Some teams have over 10 machines running simultaneously to churn out all these parts. After the design and manufacturing phases, it's time for rigorous testing before hitting the track. With around 14,500 parts in play, every single one undergoes meticulous inspection and testing before being mounted onto the car. Teams employ cutting-edge technology like coordinate measuring machines and lasers to ensure each part meets precise dimensions down to the micron. Materials are scrutinized under microscopes and subjected to non-destructive tests like X-ray or ultrasound to detect any flaws. It all kind of sounds like science fiction stuff. And honestly, some of these processes might as well be. How else do you expect these lightning-fast vehicles to blitz through entire treks within minutes? Anyways, after carefully checking the materials under microscopic conditions, it's time for dynamic test rigs to mimic on-track conditions, subjecting sub-assemblies and assemblies to extreme temperatures and motion cycles. Every component is assigned a lifespan based on mileage or usage time, with safety-critical parts undergoing even more strict testing, often exceeding their expected lifespan. Additionally, the car must pass a series of FIA crash tests, including front, rear, side impacts, and rollover scenarios, ensuring the highest safety standards. After this, you can actually see the car take its first test drive on the track. That's because after the testing phase is cleared, it's time for the car's first fire-up and shakedown. This huge moment marks the first ignition of the car's power unit, fuel system, hydraulics, transmission, and cooling system. Despite still missing its bodywork, the skeletal chassis comes to life, signaling a pretty big milestone for the team. The initial build typically takes about a week, after which the car undergoes a shakedown run or heads straight to the first preseason test, depending on how smoothly the process has gone. It's an exciting journey from design to reality, and each step brings the team closer to the adrenaline-fueled action on the racetrack. But you might wonder, just what is the shakedown? Well, before hitting the track for preseason testing, teams need to nail down every bolt and wire. This involves a trial run limited to less than 100 kilometers, ensuring that everything is snug and secure, setting the stage for fine-tuning the car's setup during testing. Once testing kicks off, it's all about tweaking and perfecting the ride to tackle the challenges of the upcoming season. But before we rev up too much, let's talk numbers. How much does it cost to field one of these beasts? Well, Formula One now operates under a cost cap, meaning each team has a ceiling on spending. In 2022, that cap was set at $140 million, dropping to $135 million or £102 million from 2023 onwards. This covers all performance-related expenses, but excludes marketing and the salaries of drivers and top team personnel. Pinpointing the exact cost of a single car is tricky due to the myriad components involved and the variations in design among teams, but it's estimated to hover around $7.5 million. Here's a breakdown. Engines take the lion's share at around $4 million each. The chassis, your car's skeleton, comes in at about $1.2 million US. The gearbox follows at around $1 million. Front wings, crucial for aerodynamics, go for $190,000 apiece, and you need plenty of them. The steering wheel, loaded with complex electronics, rings in at around $65,000. And don't overlook the tires, priced at about $2,000 per set. With teams burning through 20 sets per car race, that's an extra $75,000 per race weekend. Making these things isn't cheap, that's for sure. Anyway.